Hello and welcome back to Calculus 2, section 8.1, review of integration. As you can or cannot see in the book, on page 520 you have the chart of integrals, which is the same one as in 4.9 when you learned basic integrals. So most of the integrals that you are going to see are either going to be basic or some algebraic manipulation that you need to do to transform that integral into a basic integral or into u sub, which leads to basic integral. Now, u substitution is one of the most frequent techniques of integration, so we are technically reviewing basic integrals, u sub, and then some of the few algebraic tricks that you employ to transform the nasty-looking integral into something that is manageable. First of all, not every function that you encounter can be integrated. Some cannot be integrated at all, and for those we use numerical methods, which you will learn. Well, some numerical methods for integration you learned in Calculus 1 with Riemann's area under the curve approximation. But the more advanced and better methods are all learned in a course that it's called numerical methods or numerical analysis or something, usually 400 level, and then there are graduate upgrades to that as well. So if you cannot integrate by hand, your job would be to integrate using the software. And that's what's encouraged for labs and the project if you run into a problem that you cannot solve. Now, for us, we are going to take a look at integral of, let's say, sine x dx, integral of sine squared x dx, integral of x sine x squared dx, integral of x sine x dx, integral of sine to the 9th power x cosine x dx. Look at that. Beautiful list. This problem, it's a bad day. We should all just leave. Now, as you can see, the list of these problems, they all have sine x in them, right? All of them. And actually, I should add at the end integral of cosine. Let's do the square root of cosine x sine x dx. All right, great. So now, when you look at this list, clearly the problem on top is the basic integral that you just have to have memorized, otherwise you are doomed. So what is the integral of sine x? Negative cosine x.
Yeah, plus c.
Plus c. So it's either plus c or minus 1. So figure it out. So negative cosine x plus c. I mean minus 1 for grading, not minus 1. So that's basic, right? That's the basic integral. Then you move to the next one. Is that the basic integral? No. What do we do there? Well, you might want to say u sub, but sine needs a cosine around in order for it to have the du part, and the square needs a non-square around, so we don't have any of those features, so it's not u sub. So it's not basic, it's not u sub, which means that we need to power reduce the trig. So there are those two formulas that you absolutely must know, otherwise doom with 7 O's. This problem can only be solved if you know that sine squared x is cosine 2x, no, 1 minus cosine 2x over 2. That's the only way you can solve this problem. And as soon as you do this transformation using a basic trig identity, which you are supposed to know, then you get basic integrals, you integrate quickly, and you are done. Great. Moving on to the next problem. Now, we'll come back and we'll solve these. So the next problem now, number 3. Maybe I should number them. So number 1, number 2, 3, 4, 5, and 6. There we go. So number 3, what should we do there? What do you mean? Oh, no. We are not allowed to do that. For derivatives, you have product rule to deal with multiplication of functions. So that only works for addition and subtraction. Separate integrals only work for addition and subtraction. It does not work for multiplication or division. We have special rules for multiplication and division. But in this case, we can do something cute, something nice. So what should we do here? What are we looking for all the time? It's not basic integral, great. So the next thing you look for is U sub, function derivative pair. Do we have function derivative pair in this problem? Yeah, right? We have x squared and its derivative is 2x. Great. We can use U sub on this problem with u equal x squared. Okay, cool. Number 4. Well, you look at number 4 and then you look at number 3 and you are tempted to say the same. No. Number 4 is something that you are going to learn tomorrow. That's 8.2, integration by parts. You don't know this method yet, so I'm just going to drop that in there and we move along. I had to have it on list because you need to see that number 3 and number 4 are only different by that square. That's the only difference between the two. And the method completely changes, going from, right? And then if you take a look at 1 and 4, well, number 4 is multiplied by x, and number 1 is not. So then number 1 is basic, and number 4 is not basic. So there are a lot of subtle things in integration. Now we're going back to things you can do. Number 5. What's number 5? Is it a basic integral? You always ask yourself that first. No. Good. So if it's not basic, hopefully it's U sub. Now, do we have a function derivative pair? Yes. What is my function derivative pair there? Cosine and sine. Well, which one do I set as sine? Very good. Whichever one has the exponent is the one to go to u, because the single one will remain for du. Beautiful. How about number 6? Again, u sub. Very good. What's my function derivative pair? Cosine and sine. Again, what's u? Cosine x, because cosine has the exponent. Great. So now you have the list, and obviously we will be skipping number 4. So on this list, you saw a basic problem, you saw in identity, which is equivalent to algebraic manipulation problems, and then you have seen 3 u subs depending on which form of the problem you have. Okay, so we have these 5 problems. So we solved the first one. That was a basic integral supply. Done. We're not going to do the 4, 2, 3, 5, and 6. So let's go one at a time. So number 2, we'll use the formula. So let's go and deal with number 2 first. So we have integral of sine squared x dx. We said we are going to use the formula, which is 1 minus, help me, cosine 2x over 2 dx. So we can kick 1/2 outside of integral, and we just have to integrate 1 minus cosine 2x dx. Really? There we go. Which is equal to 1/2 open parenthesis. Integral of 1 is x, and integral of cosine is, no, derivative of cosine is negative sine. Integral of cosine is positive sine. So that's why this sign doesn't change. Stays as negative, and you get sine 2x over 2, and then we have plus c. Now, you may leave the answer this way. You can make it worse, or you can pull off the boss. The boss method. So if you make it worse, you'll just multiply 1/2 into each one of these, and you're making it worse at that point. But because x will be divided by 2, and then sine will be divided by 4, it's not the same denominator. So this is where computer scientists will cringe, right? So that's making it worse. Making it better is actually factoring additional 1/2 to make everything a quarter times 2x minus sine 2x plus c. So that's the boss move. Now, obviously, both of these would give you full credit on the test. But again, right, there are cool people, and then there are those that are not cool. Right? There's the difference. Number 3. That's the u sub of x sine x squared dx. We already established that the u is x squared. Du must be 2x dx. So we do have x. We don't have 2x, so we have to fix that. Remember, you're either using different colors or you're writing a new line for the fix. So now I have 2x dx. So all of that gets replaced by du, and then you sine u du. So the x squared gets replaced by u, so you have sine of u, and then 2x dx gets replaced by du. So now, integral of sine is, don't be shy, negative cosine. So, negative 1/2 cosine u plus c. Now, no one cares about u, right? The variable is x. So, we replace u with x, and that's negative 1/2 cosine x squared plus c. Number 4, skip, because cosine x dx. So that's our integral. And what do we do here? Well, we said that u is equal to what? Sine, good, sine x. What's the du? Cosine x dx, great. So that's exactly this piece. So try to complete this on your own. You have 18 seconds. So you should be done by now. Integral u to the 9 du, which is u to the 10, over 10 plus c, which is 1 over 10, sine to the 10th power x plus c, and we are done. Square root of cosine x, sine x, dx. So what do we have here? What do we have here? Another u sub, great. Yes, why? Yes, so we are going to use cosine this time as u because the cosine has the radical. Last time sine had the exponent. You want the single one to stay with dx because you are going to have a du part to replace dx. So if u is equal to cosine x, du is equal to negative sine x dx. You don't have a negative, so just we'll place two negatives. So now negative integral u to the 1/2 du. Because the negative sine x dx becomes, altogether becomes du. Cosine is u, so root of cosine is root u. And all I need to do now is to integrate u to the 1/2, which is the one that adds plus 1. So this is negative, open parenthesis. Well, you don't need a parenthesis. You can just say u to the 3/2 divided by 3/2 plus c, which is negative 2/3. When you bring it up, it flips. U is cosine x, so we have cosine x raised to the 3/2 plus c, and the problem is solved. I hope you will study these examples to catch subtleties between functions so that you can use appropriate technique, because in some cases it's going to be u sub, and in other cases it's going to be something from the list of problems we haven't dealt with yet. Algebraic manipulation, that was number 2. Problem number 2, where you had to use trig identity to solve the problem. There was no other way to solve that problem other than to use the trig identity to reduce the power. So let's take a look at some other exercises. So integral of x over x squared plus 1 dx, and the integral of 1 over x squared plus 1 dx. Actually, just swap them. Put the 1 up and put the x down. So put the 1 over here and put the x over here. So now we're going to consider these two problems. Problem A and problem B. Is there anything that you guys can say about this? probably too much juice. So what do we have on the first one?
Is it family members?
Yes, very good. First one is a basic integral. It's inverse tangent. So this is basic integral. You just say inverse tangent of x plus c and you walk away. That's all it is. Inverse tangent. Now the one on the bottom looks really, really close, but it's not. Yes. Yes, u sub. Exactly. The bottom is u sub. What's u? Yes. U is x squared plus 1. Du is 2x dx. I don't have the 2, so I'll plug in the 2 and a half in front. So now I have 2x dx. So it's 1/2 integral 2x dx becomes du over u. Now you'll be sick of these integrals in, I believe, 8.5 or whatever the partial fraction decomposition is. What is the integral of du over u? What do you mean ln? You can't just have ln. There we go. That's why I was waiting. Keep talking. Yes, all of you. No. Plus, yeah. Maybe you can work in pair on the test, and then I'll just split the grade evenly between the two of you. Guaranteed 50, exactly. Quizzes, I mean. It's more than 12, I mean. All right, so 1/2 ln absolute u plus c, which is 1/2 ln of absolute. Now, I don't need absolute values. Why? I can just write x squared plus 1 in parentheses, and then plus. I mean, if you write absolute value, you won't be wrong. You don't need it. It's like when you're, putting up a picture on a wall. You don't really use a 60-pound sledgehammer. You can use the little framing hammer or a remote or something. I know. But so parentheses, right, would be the framing hammer, and absolute would be the sledgehammer. So why am I, in this particular problem, why am I allowed to drop absolute values? Yes? Excellent. X squared plus 1 can never be negative, because any number squared, whether it's positive or negative, will always be positive, and then you add 1. Right? So even if x was 0, this will still be positive number, right? So in just this particular case, I mean, you could have x squared plus 3 or x, right? You can't have it as x squared minus 1, because x squared minus 1, you can come up with negative numbers, and right? So starting at x squared plus 1 and up, plus 2, plus 2.5 or whatever, plus pi, whatever you want, then we can drop absolute values. And in other cases, you can. So if argument is in any way possible to be 0, you have to have absolute values. And if it can only be positive, then you can put either of the two. Now, obviously, the safe call is to always put absolute values. But then, all right, good. So we said that the integral of ln x dx is in 8.2, so we don't mess with that one. We have to learn a technique, a method to compute this integral, so we don't do this one. But then we can say, how about 6 divided by x ln x squared? Well, looks awful enough. By the way, this ln x squared you can also write as ln squared x. It follows the same notation as trig, when that squared that is directly on sine or cosine or tangent or ln means it's sine times sine. But we can also write it this way, it's okay. It's the same thing. So we cannot integrate ln x yet, but then for some reason we can integrate the problem on the bottom. Why? How? U sub. Why? How?
Derivative of ln x is 1 over x.
Beautiful. You are always looking for function derivative pair if you are to be successful with u sub. So, dare I say clearly, you have ln x present and its derivative 1 over x is also present. So I don't care where ln x is, top, bottom, whether it's squared or to the 10th power, I really don't care. It could be square root of ln x. It doesn't matter. I just need ln x because the derivative of ln x is 1 over x and I have 1 over x. So u is ln x, du is 1 over x dx. Perfect. So we kick 6 outside. My 1 over x dx becomes du, and ln x squared in denominator becomes u squared. This is 6 integral u to the minus 2 du. What's the integral of u to the minus 2? Very good. U to the minus 1 over minus 1 plus c, and now we make it pretty. That's negative 6 over u plus c, which is negative 6 over ln x plus c. Now let's say you care, right? Hypothetically, tomorrow is exam. So let's say you care. You want to make sure that every single problem is correct before you hand the test in, right? Let's say we care. The whole test is integration. Woohoo! You can take the derivative of every single answer you got, and if you get where you started with, it's 100% correct. You can literally walk to the desk and say, just put 100. Because you know, right? There is no, I think I did well. I hope I did well. Just take the derivatives, right? For every problem we had prior to this one, you can just go and say, check. You can do this on the margin. Every other page on the exam will be blank. You can use that space to take these derivatives and make sure that your integration is 100% good. So all I need to do is to differentiate negative 6 over ln x. I don't have to worry about plus c because the derivative of plus c is 0. So, bye. So all I need to do is to differentiate this. And if I get what I have up there, I'm done. So let's see what we get. I start by rewriting the problem as d dx is a negative 6 times ln x to the minus 1. Because I don't want to do the quotient rule because negative 6 is not a function. Again, no need for a sledgehammer if this is a basic chain rule problem with that negative 1 dropping down as you differentiate. So what do I have? I have negative 6 times negative 1 ln of x to the negative 2, because when you're differentiating, it's exponent minus 1. So minus 1 is minus 2, times the derivative of the inside, which is 1 over x, because that's your chain rule. So now you have your negative 6 times negative 1 is positive 6. And you have your ln x is going to be 1 over ln x squared, and you have times 1 over x. Well, this is 6 over x ln x squared, which is our problem. So we know for sure, 100%, that the solution to this problem is correct, because it worked out in a derivative. So now you can go back, and every single integral we ever did in this class, or Calc 1, if it's correct, the derivative will go back to the statement of the problem, which is right here. Antiderivatives. Now, clearly, you have to want to do that, right? You can't be lazy. That's the big deterrent, right? Yeah, it's good. It looks good. Move along. Because if it's wrong, and then I know it's wrong, I have to do it again, right? It's much easier to have a worse grade than to redo a problem that you know for sure it's wrong because the derivative didn't work out, right? Yeah, it's called the least resistance, the line of least resistance. Because you can always repeat the course. Well, no, it's not a problem because this is 4 times cheaper than Rutgers, so you have 4 shots here for 1 shot at Rutgers. This is about 6 to 7 times cheaper than Cornell or RPI, so you have 7 shots or Penn State. 7 shots at Calc 2 before you can, right? You know that this course is $4,200 at some of these schools. $4,200. It's a lot of cat food, guys. Yes? I believe it's 3 you pay. Might be 4.
You can do it.
I don't know, it's just...
Once you hit the limit, you just got to get approval from the dean.
Oh!
Yeah.
And then you just move to the next school, exactly, right? So you can be a student pledge. How much? As much as you can get loan. which you can't declare bankruptcy on, which you can't pay when you go to jail. You know that? The only loan you can't declare bankruptcy. You declare bankruptcy on a house, they repossess your house, and then you just go and live somewhere else. You can't pay your car, they take away your car. Because the bank has the title and the deed and all of these things, right? Can they come in and take the knowledge out of your head? So in a law, you can't, the only loan that you can declare bankruptcy on is if you have student loans. For that, when you go to jail, you go to prison, Baba J, to see what's on it. There you go. All right. Yeah, see then if you want to take $60K in loans for a useless degree, you can do anything with.
Underwater basket.
Whatever, along those lines. There's way too many of them today. All right. Let's take a look at some of the spicier problems from the book. Now, some of the stuff that they have here is just pure evil. I mean, you look at these things and you quit life, pretty much. But then some, you can deal with. So let's take a look at problem 47, integral of dx over x to the minus 1 plus 1. Yeah, bad, but doable, hopefully. Any ideas? No? It's terrible, huh? I don't know either. Let's see. So integral of 1 over x plus 1, and I'll put dx on the side. Is there anything that naturally comes to mind when you see something like this? Take, what did you say? So you multiply both by x to get rid of the double fraction, and that will bring x up top, yes. So times x, because x over x is 1. And once you do this, the problem changes into x divided by 1 plus x dx. All right, well, that's a little better. Still not there. Do I have function derivative pair? No, because I need x squared on the bottom for a single x on top. Remember we did that? They looked like an inverse tangent, but it wasn't. It was u sub. So, what now? By the way, this section is more important than any of the review you're going to see. Remember what your exam is. You memorizing a whole bunch of formulas. That's your first exam. Do you know the formula for disk method, shell method, washer, length of the curve, surface area of revolution? Did you memorize the pumping formula, the work formula? You need to memorize at most 10 formulas, and that's your exam 1. If you can't integrate, if you can't do 8-1, well, guess what? You can't solve any of those problems. You get 2 points for knowing each formula, 2 out of 10, for memorizing each formula for each of the problems, and your score is 20 out of 100, plus quizzes. So studying 8-1, which is a method of integration, which is what you covered so far, we are not learning anything new today. We are reviewing U sub, and all of these things. So now this is our new problem, which is the same as above. It just looks different. So what do we have here? No.
Can you do like U sub and then I subtract the 1 from the U side?
Huh. Very good. It's called the back substitution. I talked about it the first day, and we should be able to do that. Sounds like a deal. Is there anything else that could possibly work here? Well, maybe. Maybe you can divide using the long division of polynomials. Maybe you can divide. So those are the two, and if those two things don't work, well, then we're in trouble, right? Because those are the only two methods that would be available to us at this moment in time. So number 1, let's try back substituting. If that doesn't work, then we're going to do the division of polynomials, and if that doesn't work, then we're doomed. So U sub, which is called the back sub, so let's go orange. Back sub. It's called backward substitution or backwards U substitution or whatever. U is equal to x plus 1. Du is equal to dx. So now when you want to plug this stuff in, you notice that you don't have anything to plug in for x on top. So you solve this one for x, which is u minus 1. So now x on top is u minus 1. The bottom is u, and dx equals du. Yes. Now, because you have a fraction that has a subtraction in the numerator, you can break it into 2 fractions. Common denominator is u. You can break into 2 fractions, and because it's a minus, you can separate 2 integrals. Because it's a minus. So plus and minus allow you to separate integrals. Multiplication and division do not, which is why, because of multiplication and division, we have the entire chapter 8. So I can separate this into u over u du minus integral of 1 over u du. Now clearly this cancels to 1, so the integral of and then plus c. Maybe you should join these 3 guys so you can make it. It's now going to be 33.3% for everyone because of the plus c. You can complement each other. So we have the ln of u plus c. Now, as it always goes, no one cares about u, so it's x plus 1 plus ln x plus 1 in parentheses in the absolute values, right? And then plus c. So we have to use absolute value here because if you say x is negative 10 plus 1 is negative 9, and ln is not going to be happy. I mean, ln is going to be happy, it's just that you are not happy because your answer is not real. It's going to be imaginary value, complex number. It's not impossible to take ln of negative number. It's just you're not there yet. All right? That's the bottom. pretty much everything you see in math, someone says, no. You're just not there yet. Eventually you will get there and it will be right, if you want to take more math. So anytime you have ln of a negative number, you're getting a complex value, like 2 plus 3i or something like that. And if it's a positive number, you're getting real numbers, 7.3451, whatever. Well, that was a good, right, the back sub, that worked. But the crucial point was multiplying top and bottom by x to get rid of the double fraction, and once you are done with the double fraction, then we're good. Lock the doors. 61. Integral of e to the x divided by e to the 2x plus 2e to the x plus 1 dx. Now, if you are to become a tutor at our tutoring center here at a college, or you tutor private or whatever, this problem would be instant for you to solve. Just by looking at it, you would solve it. Yes? Excellent. Algebra. You have a trinomial on the bottom, which is similar to x squared plus 2x plus 1, that compresses into x squared plus 1, everything squared. So this thing with ease would just compress into e to the x plus 1, everything squared. So that's something that we do a lot in algebra courses. So if you are a tutor, you will be seeing this so much over the semester that when you run into it in a class like this in calculus instantly, you actually don't see this at all. You just see it as e to the x plus 1 squared immediately. As soon as your eyes hit this, your brain registers the line underneath. But that's if you're a tutor. So now we have e to the x divided by e to the x plus 1 squared dx. Great. Algebra part helped us out to get here. Now what? U sub. Fine. What's u? E to the x plus 1. What's du? E to the x dx. Yeah, this dx is not there for decoration. It's this one, right? We need it. So now, as you plug this in, you have the integral. E to the x dx is du. And on the bottom, you have u squared. So this is integral of u to the minus 2 du, which is u to the minus 1 over negative 1 plus c, negative 1 over e to the x plus 1 plus c. Oh, at one point I put this problem on the exam and half of the classroom spontaneously combusted. Four plus e to the negative 2x divided, I mean, it was something similar to this, 3x dx. What's the verdict on this one? So cheap, yes. Yes. Split them, bring all of the e's upstairs, combine them, and just integrate. It's basic e problem. Takes 2 seconds. So, first integral is going to be 4 over e to the 3x dx, and then you have plus the second integral is e to the minus 2x over e to the 3x. Because you have common denominator e to the 3x. You can split into 2 fractions, and because there is a plus, you can split into 2 separate integrals. Once you're there, you have the first integral kick 4 outside, you have e to the negative 3x dx, plus integral of e to the negative 5x dx, because you have negative 2x divided by negative 3x that they subtract, so minus 2x minus 3x is negative 5x. And now these are basic integrals for e to the negative 3x over negative 3 plus e to the negative 5x over negative 5 plus c, and then you make it pretty, which is negative 4/3, and then you have e to the 3x positive minus 1 over 5e to the 5x plus c. So easy when you see it done, right? Wouldn't you agree that it's so easy when you see athletes run on TV at Olympics? You tried it? No, yeah. Oh, okay. Right? Always remember that. I remember one time when I asked some, it was a spicier problem, and I waited for classroom for some time to we'll do the problem and didn't get far. Then I started working on a problem. Another student started asking questions, and one of the students said, shh, just observe him in his natural habitat. I will never forget it. It's been probably at least 5 years since that. Just observe him in his natural habitat. All right. That's enough. I mean, you have a list of 70 integrals over there in the book. We did like, what, 15, 20? So, if it's basic, you integrate. Be mindful of algebra. Usually that is the time when you can't do the integral because you're overseeing some basic algebraic rules. Let's take a few moments break. When we come back, I'm going to go through the list of all topics and ideas, make sure you guys know all of the formulas and stuff, and that will be it.